Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 5 in the SSRF module, titled SSRF with Filter Bypass via Open Redirection Vulnerability. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Go down, select the learning path, go down, select server-side request forgery, go down one more time, and select lab number 5 titled SSRF with Filter Bypass via Open Redirection Vulnerability. Alright, let's get started. This lab has a stock check feature which fetches data from an internal system. To solve the lab, change the stock check URL to access the admin interface at 192.168.0.12, running on port 8080/admin, and delete the user Carlos. The stock checker has been restricted to only access the local application, so you will need to find an open redirect affecting the application first. Alright, so our vulnerable feature is the stock check functionality, and the goal of the exercise is to change the stock check URL to access the admin interface and delete the user Carlos. So let's put that in here and click on view, toggle word wrap. Alright, this looks much better, and let's create our analysis section. Alright, so the defense for SSRF has been implemented correctly over here, and so we can't use any of the techniques that we used in previous labs. Instead, we're going to have to find an open redirect vulnerability that will allow us to perform an SSRF exploit. So let's right click and access the lab. And in the meantime, open up Burp Suite Professional. So I'm using the professional version of Burp because I want to use the render feature when it comes to requests. However, that's not necessary in order to complete the exercise. So if you don't have the professional version, it's completely okay. You could use the community edition. Let's hit OK and put it over here and go to the proxy tab. Alright, let's set our browser to send requests to Burp and click on View Details for the first product. Hit forward, forward again. Alright, and if we go down, we've got a check stock feature, so let's click on that and send this one to repeater. That's the check stock feature that we've been dealing with in the past couple of labs. So send to repeater. But notice over here, so first let's forward. And then notice over here, there's also a next product. So let's click on that and send this to a repeater as well. That's a new functionality that we didn't see in previous labs. So let's forward it one more time and set intercept to off. Now go back to repeater and let's name our tabs. So this was the check stock feature and this was the next product feature. Alright, let's test the check stock feature first. So let's do Ctrl+Shift+U to URL decode it, and it's not using a URL, so that's interesting. It's using the path to the application. So it's using the path to the feature that it wants to visit. So in this case, it's product/stock/check product ID is equal to 1. And then when you hit send, it says missing parameter because it's not URL encoded. So if you do Ctrl+Shift+U or Ctrl+U to URL encode it, it gives you the number of items that are available for this product. Okay, so if we give it let's say HTTP localhost, it's likely not going to work because what's going to happen, it's going to append this to the URL of the system that is used in order to check items, which we've seen it in previous labs. It was something like iliketoshop.net. So if we hit send, it says invalid external stock check URL and invalid URL. So this doesn't work. Let's go back. what we're going to do is we need to become creative and try to exploit this vulnerability without having to put in a URL over here, at least not directly. So if we look at next product over here, notice that there's a path variable that if you hit send, what it's going to do, it's going to redirect you to this path in the application. So if we follow redirection, notice over here, it got you to the page product where the product ID is equal to 2. So this is redirecting you to a different location in the application. Let's see if it's vulnerable to an open redirect vulnerability. That's a vulnerability where the application will redirect you to an arbitrary URL. So let's say https www.google.com and see if it redirects us to google.com. Okay, we get a 302, that's a good sign. And if we render over here, we're at the Google page. So this is definitely vulnerable to an open redirect vulnerability. And we're going to use that in order to exploit the SSRF vulnerability in the checkstock feature. All right, so the way to do that is instead of have /product/stock/check and then the product ID, what we're going to do is remove this over here and go back to next product and add this path. Now this should be accepted by the system because this is a valid path in the application. So let's copy it and paste it in here. However, instead of the path being /product, where the product ID is equal to 2, what we're going to do is we're going to add the path to the internal system that has the admin interface. So it's HTTP. And we had that in the exercise over here. /admin. So in a real world scenario where you don't have the IP address, what you would do is fuzz the application with all the possible IP addresses until you get one that is running on port 8080. And then from there, you fuzz the application in order to find valid directories, which in this case is admin. But we've done that in one of the previous labs, and so I'm not going to show it in this lab over here. Instead, I'm going to assume that we know the path and we enter it over here. So what's going to happen over here is that the application is first going to validate that the supplied stock API URL is an allowed domain, which it is because, you know, it's coming from /product/next product. And then the application will request the supplied URL, which triggers the open redirect vulnerability. From the path variable, it follows the redirection and makes the request to the internal URL of the attacker's choosing. And so this way you bypass the defenses that were put for SSRF and exploited the vulnerability. So if we hit send, we should see the admin page and we see a missing parameter path. So what we're going to do is URL encode this. So Control U to URL encode it, hit send, and here we go. We get a 200 response. If we render, we're at the admin page. So I'm just going to copy this right over here and add it in here. So admin page /admin. And then the next thing we want to do is delete the user. So delete user. We're going to go back here, go to raw, and click on and find the user Carlos. And here's the path to delete the user. So it's HTTP 192.168.0.12. And we've got Carlos right over here. Let's copy that. And let's put it under the path variable. So I'm just going to URL decode this one more time. Control-Shift-U, put it in here, and then URL encode it again, just so that I don't make any mistakes. So let's paste this. And then URL encode the entire thing. So Control-U, hit send. And here we go. We deleted the Carlos user, and so we get a congratulations, you solved the lab message. And if we visit the admin page again, hit send, and click on render, we no longer see the Carlos user because the Carlos user no longer exists. All right, so we successfully completed the exercise by using an open redirect vulnerability in order to perform an SSRF vulnerability. The next thing we're going to do is script the exercise in Python. So let's save this over here and go to our Python script. The first thing we're going to do is import the necessary libraries. So import requests, import sys, and import URL lib3. I'm also going to disable any request warnings. So .disable warning URL lib3 .exceptions .insecure request warning. All right, this looks good. And then I'm going to create my proxies variable. And what that will do is it'll allow me to send all the requests that the script is making to burp. And that helps when it comes to debugging the application in case it doesn't work. So 127.0.0.1, and it's on port 8080. And we'll do that for HTTPS as well. All right, let's click on view and toggle word wrap. That looks much better. Next, we're going to create our main method. So if name is equal to main, then call the main method. And we'll create that right over here. So if the length of the command line arguments that you used in order to run the program is not equal to 2, then print the following messages. The usage instructions, which is running the program using the program name, followed by the URL. I'm also going to print example instructions just so that it's completely clear. Again, name of the program followed by an example URL. So let's say www.example. And then I'm going to exit the program because you ran it incorrectly. And assuming you do run it correctly, I'm going to take in the first command line argument and save it in a variable called URL. And then I'm going to print the message deleting Carlos user. And in order to do that, I'm going to call a function called delete user that takes in the URL. All right, let's implement that function. So def delete user URL. First, we're going to create a variable called delete user SSRF payload. And that's going to be the payload that is used in order to delete the user, which is this one over here. However, this one is URL encoded. And what's going to happen is that the request libraries is going to encode whatever variable we use over here. So we need a decoded version of this one. So if we go back to burp, put it in here, go back. And I'm going to do Control-Shift-U to URL decode it. And copy this entire thing over here. And let's put it in here for reference and in here as well. All right. Next, we need a variable for the path to the vulnerable page, which we get from over here. So it was /product/stock. So let's copy that, put it in here. And then we've got a params variable, which is the parameters that are included in the request. And we only have one, which is stock API. So copy that, put it in here. And the value of the stock API is going to be the delete user SSRF payload. And then what's left is to make the request. So request.post. We're using a post method because this is a post request. So it takes in the URL plus the check stock path. And then it takes in the parameters to the request, which is params. And then verify is equal to false because I don't want to verify TLS certificates. And I want the request to be sent to burp. So I'm going to set proxies to be equal to proxies. So what this is going to do is it's going to perform this exact request over here that deletes the Carlos user. All right, the next step is to check if the user is deleted. And the way we're going to do that is by creating another variable called admin page SSRF payload. And that one was the second request that we made, where we called the admin page to see if the Carlos user is still available on the page. Again, this is URL encoded, so we're going to do Control-Shift-U to decode it. Let's copy it, put it in here, and let's save it in our notes as well for future reference. All right, this looks good. Next, we need a params2 variable. And again, that's going to be stock API. And it'll be the admin page SSRF payload. And then we're going to make our request. So request.post. It would be URL plus check stock path. Data is going to equal to params2. And then verify will be equal to false. And proxies is equal to proxies. And then we're going to confirm that the user is deleted by saying if Carlos is not in r.text, so the response text, then print successfully deleted Carlos user. Otherwise, print exploit was unsuccessful. Alright, this looks good. Let's save it. And what this is going to do is check if the user is deleted. So it'll make this request over here, check if Carlos is on the page. If Carlos is on the page, that means the exploit was unsuccessful. If Carlos was not on the page, that means we've successfully deleted the Carlos user. So we've saved this. Let's go to terminal, new terminal. Do Python 3 SSRF lab 05.py and the URL of the application, which likely timed out. And it did not, which is super weird. So let's copy this. We might have written the script way too fast. So let's paste it over here and remove this entire thing. And before we run it, I'm going to go to proxy, HTTP history, and hit enter. And we get an error. So on line number 7, we've got proxies is equal to HTTP. That looks good. Okay, and it's not the proxies that is an error. It's this one over here. So there's, for some reason, 2 curly brackets. So let's save it, clear it, and run it again. And here we go. It says it successfully deleted the Carlos user. So if we look over here, the first request that it made was to delete the user. And then the second request was for the admin page. It looked for Carlos in the admin page. It didn't find the Carlos user. And if we click on render, you can't see the Carlos user. And so it displayed the message successfully deleted the Carlos user. Alright, so we've successfully completed the exercise by first exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at blind-based SSRF vulnerabilities.